Hey guys, this is chapter prerequisite, part 3, polynomials. This should be a little bit of like a brain break a little bit for us, a reminder of adding, subtracting, and multiplying polynomials. So let's go ahead and work through it. Polynomial means, the word poly means many, and nomial is what we're going to refer to terms. So this is an example of a polynomial. Polynomials are made up of, like I said, different terms, and they are all separated by plus or minus signs. So here is a term, here is a term, here is a term. And the sign in front of the term stays with that. So we have a positive 3x to the fourth, a negative 5x squared, and 7 is considered our three terms. The numbers that are considered coefficients, that's a number in front of a variable, would be our 3 and negative 5. And then 7, the number without a variable, is called a constant. If and when you are asked to put something in standard form, that means you would put it where the degrees are in descending order, meaning the highest exponent goes first and then it goes down from there. If you were to be asked what is the degree of this polynomial, that simply just means the highest exponent that you see. So the degree of a polynomial is just the highest exponent you see. And a polynomial that has one term is called a monomial. Mono means one. A polynomial that has two terms, see this 3x to the fourth and a 7 that's separated by a plus sign, is a binomial. That means two terms. Here we have three terms, 3x to the fourth, negative 5x squared, and a positive 7, that's a trinomial. That means three terms. When you have more than three terms, it's just considered a polynomial. And like I just mentioned on the slide before, this is considered to be in standing form because the exponents go in decreasing order. 4, 3, 2, this is 1, and this would be x to the 0, which would be your constant, because anything to the 0 power is what? 1. Okay. So over here on the left-hand side, where I'm going to put a blue star, these are examples of polynomials. We have 3x squared. You can have variables with varying exponents. You can have fractions in front of variables, and you can have mathematical symbols. What you can't have, what is not considered a polynomial, would be negative exponents, exponents that are variables, square roots, or rational exponents. So just be careful and stuff like that. Another thing that you cannot have is a variable in the denominator. That is not considered a polynomial. So if we were asked, and this is asking us to rewrite the polynomial in standard form, then state the degree, leading coefficient, and classify it by the number of terms. So standard form means you start with the highest exponent. So in this case, I look here, I say the highest exponent is x to the 6th. That's a positive, so it's 5x to the 6th. The next exponent would be our x cubed. That's a positive because there's no sign in front of it, so it'd be plus 4x cubed. And then last we have our x squared. That minus sign stays with it, so it's minus 21x squared. Now, if we're asked to state the degree is our highest exponent, so you would say that the degree is 6. The leading coefficient, that's the line leader. That's the number that's in front of the biggest degree, so your leading coefficient is 5. And we're going to classify by the number of terms. So I have 1, 2, 3 terms, so this is a tri, meaning three, nomial. Our second example here, we're going to write in standard form. That means we start with the highest exponent. Well, this negative is going to stay with that, so it's negative 5y to the 7th. Then I have plus 6y cubed. So our degree, our highest exponent, is 7. You would say the degree of this is 7. The line leader, what's starting out in front of our biggest degree, our leading coefficient is going to be negative 5. And if I was going to categorize this by the number of terms, there's 2 terms. So this would be a bi, meaning 2, nomial. We've talked a little bit with our radicals and stuff like that about combining like terms. When we say like terms, a lot of the times you guys will know that I've said the same last name, meaning the variable is the same and the exponent. So the variables and exponent have to be identical, and then we add or subtract coefficients. So in this first example, the first thing I always tell everybody to do is look in the middle of the parentheses. That'll tell you what you're doing. If there's a plus sign, you're adding. If there's a minus sign, you're subtracting. And then if they're stuck together, that means you multiply. So in this case, all we're doing is adding. We don't have to distribute, we don't have to do anything. We just have to combine like terms. So I like to circle. What else has a y squared? Y squared is our biggest exponent. So I say 4 plus a negative 7 gives me negative 3, and that's y squared. Do I have anything with just y to the first? No. So then I look and I say, okay, well, I have a negative 3 here and a positive 9. So negative 3 plus 9 gives me plus 6. And there we have combined like terms. Same thing here. Let's look in the middle. What is the sign in the middle? It's a plus sign. So that means, okay, cool, just combine like terms. So I have a positive 5x cubed and a positive x cubed. So 5 plus 1 gives me 6, 6x cubed. I have a negative 7x squared and a positive 2. So negative 7 plus 2 gives me negative 5x squared. Then I have a negative x over here. I have nothing else that's to the first power, so I'm just going to write minus x. And then the last thing I'm going to do is combine my negative 3 with my positive 8. So negative 3 plus 8 gives me plus 5. And that's where we're at. Now, number 3 is a little different because there's a minus sign here. So when there's a minus sign, we have to pretend like there's a 1 right there. So what we have to do before we combine like terms is we have to distribute this negative sign to everything in the second parenthesis. So my first parenthesis is going to stay the same, 2x squared plus 1. Then I have to distribute that negative. So it's minus x squared. A negative times a negative is a positive 2x. And then a negative 1 times a positive 1 is a negative 1. And now that we've distributed that negative, we can combine like terms. So I have a positive 2x squared and a negative 1x squared, leaves me with x squared. I have a positive 2x, nothing else has an x with it, so plus 2x. And then I have a positive 1 and a negative 1, so those will just cancel, and then that's what we're left with. All right, a couple more examples. These get a little more involved. So again, when we have a bunch of parentheses and that sort of thing, we want to look in between to see what we're doing. In this case, we're not adding, we're not multiplying, we're subtracting. So we need to remember to distribute that negative and then combine like terms. So we still have our 7x to the 4th minus x squared minus 4x plus 2. Then I'm going to distribute that negative. So it's minus 3x to the 4th. Negative times a negative is a positive 4x squared. Negative times a positive is a minus 3x. And then now we go through and we combine like terms. So I look to see what the highest exponent is. The highest exponent I see is 3x, or x to the 4th. So I have 7x to the 4th minus 3x to the 4th gives me 4x to the 4th. So then we have x squared. So negative x squared and a positive 4x squared gives me plus 3x squared. Negative 4x and a negative 3x is going to give me a negative 7x. And then lastly, I have a positive 2 that's just hanging on by itself. So then we say plus 2. When we come to a situation with lots of parentheses and brackets, you guys want to remember to work from the inside out. I'm going to say that, inside out. And then once we do that, we want to work from left to right. So I notice here that I have a bracket with parentheses inside. I need to work inside there. So I'm going to keep, my stylus is dead, so I'm doing this with my finger. I'm going to keep y cubed plus 1 here with this minus sign. And then I'm going to go and work from the inside out. Since we are adding right here inside my parentheses, I can just combine like terms. So nothing else has a y squared, so I have y squared. Nothing else has a 3y, so plus 3y. And then I see that I have a positive 1 and a negative 7, so it's going to give me a negative 6. Now, before I can go ahead and subtract, I have to distribute this negative to everything in here. So I have y cubed plus 1 minus y squared minus 3y, and then a negative times a negative is a plus 6. And now that we've done all the simplification with distributing and all that, we can go ahead and combine like terms. So the only y cubed I see is the first one, y cubed. The only thing with y squared I see is minus y squared. And then the only thing I see with a y is minus 3y. And then we say a positive 1 and a positive 6 gives me plus 7. Now, when we look at number 6, again, look in between the signs. You are subtracting and adding. You are not multiplying. So the only thing we have to do here before we combine like terms is to take this negative sign and distribute it. So I'm just going to rewrite 6x cubed minus x squared plus 1. Then we have minus 2x squared. A negative times a negative is a positive 4. And then that's a plus, so everything back there just stays. So plus 3x cubed minus 4. So let's go ahead and survey the situation. The highest exponent I see is x cubed. So let's combine our x cubes. I have 6x cubes and 3x cubes. Gives me 9x cubed. X squares I see are negative x squared and a negative 2x squared. So it's going to give me negative 3x squares. And then I have positive 1 plus 4 is 5, minus 4 is 1. And there we have, go ahead, it's simplified and combine like terms. The next we're going to talk about is multiplying polynomials. When you guys multiply polynomials, we're going to multiply the coefficients. Right, the numbers in front of the variables, we're going to multiply together. And then when we have variables that have the same base, we're going to add the exponents. Nothing is new here. We just took a quiz and a test doing this. We're going to do the same thing. If you have two binomials, if you have two parentheses next to each other, that's when we're going to FOIL. And then you're going to combine any like terms that are a result. So when I look at this, all that number 7 is asking us to do is to take this x and to distribute it to everything inside. So this is x to the first times 3x squared. So I'm going to multiply my coefficients. 1 times 3 is 3. Then x to the first times x to the second gives me x to the third. Then I have x times negative x is going to give me negative x squared. And then x times 1 is just plus x. And then that's it. All right. Same thing here. We're going to take this negative 3x squared and distribute to everything inside. So negative 3 times 5 is negative 15. X squared times x to the first is x to the third. Then I have negative 3x squared times 2 is negative 6. And then that just have the last name of x squared. Now I can't combine anything else here, guys, because the last name is not the same. That last name is x cubed. That one is x squared. Can't do anything else. Again, same thing. We're going to take this y squared, and they just want us to distribute it to everything inside. So 1 times 4 is 4. Y squared times y squared is y to the fourth. Y squared times 2y is plus 2y. We're going to add exponents to the third. And then y squared plus 3 is plus 3y squared. And then lastly, we see we're distributing, but our 2y cubed is at the back. If you don't like the way that looks, move it to the front. 2y cubed in the front, and then you have 2 minus 3y, and go ahead and distribute. 2 times 2 is 4, y cubed. Then we have 2y times negative 3y. It's minus 6. If I have 3 on the outside, 1 on the inside, that gives me a total of 4. All right, these 4 examples are binomial times a binomial. This is where you're going to FOIL. The next thing we're going to do is factor, where we're going to have a trinomial together, and then we're going to pull it apart. But in this case, we're just going to factor and combine like terms. So first times first, x times x, x squared. Outers times outers, x times 4 is plus 4x. Then the insides together, negative 8 and x is minus x, 8x, sorry. And then the last, negative 8 and 4 is negative 32. And then combine like terms in the middle. So x squared minus 4x minus 32. Same thing on the next one. It's a binomial times a binomial. Notice there's no sign there. They're just stuck together, so you're going to FOIL. 3x times 5x. Well, 3 times 5 is 15. X times x is x squared. 3x times 7, so 3 times 7 is plus 21. Just stick the x on. Negative 2 times 5x. Negative 2 times 5 is negative 10. Stick the x on. And negative 2 times 7 is minus 14. And then we're going to combine like terms in the middle. So you have 15x squared plus 21 minus 10 is 11x minus 14. Right, same thing up here. First times first, 2x times x is 2x squared. 2x times 5 gives me plus 10x. Negative 4 times x is negative 4x. And negative 4 times 5 is minus 20. And then inside we can combine. So 2x squared, positive 10 minus 4 is plus 6x, and then minus 20. And lastly, we're going to do this one. So 7x squared times 4x. Well, 7 times 4 is 28. X squared times x is x cubed. 7x squared and negative 3 is minus 21 x squared. Then negative 2 times 4 is minus 8x to the fourth. And then negative 2 and negative 3 is going to be plus 6. And now we look and we say, okay, does anything have a like term? Is there anything we can combine? So I have x cubed, x squared, x to the first, and nothing. So there's nothing else we can combine. That's just where we're at. And sometimes that'll happen, guys. Sometimes it'll happen where, like in this case up here, you can combine because they have the same last name. Down here you can't because they don't. So just pay attention to that. And then lastly, you have these big, long problems, and these can get super messy. So this is why we have to really take our time and pay attention. I like to use different colors here. So what this first question is asking is to take x and to distribute it into the second parenthesis, and then the 4, and then combine like terms. So we're going to take x here. So x times x squared is x cubed. X times negative 2x is minus 2x squared. And then x times 3 is plus 3x. And remember, you guys are welcome to use my color pencils and all that stuff. So now we're going to take 4. So 4 times x squared is plus 4x squared. 4 times negative 2x is minus 8x. And 4 times 3 is 12. And now we look to see, does anything have the same last name? Anything with an x cubed other than this one? Nope. So we have x cubed. As far as 2x or x squareds go, we have a negative 2x squared and a positive 4x. So it's going to be plus 2x squared. I have a positive 3x and a negative 8x. That's going to give me minus 5x. And then our plus 12. All right, so I'm going to come over here to 13, and then we'll do 12 and 14 because those are kind of yucky. Again, we're going to distribute the 2x to everything, the negative 3 to everything, and then combine like terms. So 2x times x squared is 2x cubed. 2x times 3x is plus 6x squared. 2x times 5 is going to give me plus 10x. Now I'm going to take negative 3. Negative 3 times x squared is minus 3x squared. Negative 3 and a positive 3 is going to give me minus 9x. And negative 3 times 5 is negative 15. And then we look and we say, okay, what has the same last name? What can we combine? So I look at x cubes. Nothing other than this one, so it's just 2x cubed. I should probably write a 3. That's ugly. Let me rewrite that. Hang on. Okay, cubed. That's still ugly. Cubed. Ay. So now I have positive 6x squared and a negative 3x squared. That's going to give me plus 3x squared. Positive 10x and a negative 9x. That's plus 1x. And then I'm going to follow that with my negative 15. Now questions, guys, like 12 and 14, these are a mess. This is a lot. You've got to really, really, really be organized. You are distributing, in a sense, 3 different times. The first thing we're going to do is we're going to take our 2x squared and multiply it to everything back here. So 2x squared times x squared is 2x to the 4th. 2x squared and 3x is plus 6x cubed. And then 2x squared and 2 is plus 4x squared. So now I'm going to take my negative x. Negative x and x squared is minus x cubed. Negative x and 3x is minus 3x squared. and negative x and 2 is minus 2x. And now I'm going to distribute my 4. So 4 times x squared is plus 4x squared. 4 times 3x is plus 12x. And then 4 times 2 is plus 8. And then we have to combine all of our like terms. This is where we're going to be real careful. I'm going to start off with x to the 4th. Is there anything that has an x to the 4th other than this first one? No. So I'm just going to rewrite 2x to the 4th. So let's look at our x cubed. So I have 6x cubed minus 1x cubed gives me 5. Nothing else, so plus 5x cubed. Then I'm going to look at my squared. So I have a positive 4x squared and another positive 4x squared. Well, 4 plus 4 is 8, so plus 8x squared. I need another color. Let's go pink. So then I have, oh, I missed one, guys. Uh-oh, go back here. Hopefully you guys were yelling at the TV like, wait, there was another one. All right, so I have 4x squared minus 3x squared. That's 1x squared. Plus 4 gives me 5x squared. Good catch, whoever saw that and said, wait a second. Then I have negative 2x plus 12x is going to give me a plus 10. And then I have a little back here stuck with my plus 8. Those are tough problems just because they're long. They can be really messy, so we just have to be careful. Again, you saw I made a silly mistake. So here we go. We're going to do this last one, and then we're done. You guys can go ahead and start your homework. You can have a wonderful 3-day weekend, and I will see you on Tuesday when we get back. But we're going to take 3x squared and go to x squared. This is going to give me 3x to the 4th. 3x squared to 2x is going to give me plus 6x to the 3rd. And then 3x squared and 3 is going to give me plus 9x squared. So now, excuse me, now I'm going to deal with my 4x. So 4x times x squared is plus 4x cubed. 4x times 2x is going to give me plus 8x squared. Then 4x times 3 is going to give me plus 12x. And then now I'm off the screen with my negative 4. I'm going to go negative 4 to x squared is minus 4x squared. Negative 4 to 2x is minus 8x. And then negative 4 and 3 is minus 12. And we look back here and we say, holy moly, we got a lot of terms that we got to look at. So let's start with x to the 4th. Is there anything that we can combine with x to the 4th? No. So we're just going to rewrite it as 3x to the 4th. So now let's check our x to the thirds. I have a positive 6x third plus 4x third. That gives me 10 minus 4. So 10 minus 4 is going to give me a positive 6x cubed. Then I'm going to go ahead and say, all right, let's get our x squared. So I have a 9x squared plus 8x squared is 17x squared minus 8x squared. Well, that's going to give me plus 9. Oh, no, that's not squared. Oh, my goodness. Mrs. Meadows, what are you doing? It's late. Sorry, 9x squared plus 8x squared is going to give us our plus 17x squared. So now I'm going to look and I have a positive 12x and a negative 8x. Well, 12 minus 8 is plus 4x. And then we have our little old negative 12 hanging out back here. And again, guys, there's nothing else you can combine here because they don't all have the same last name. So when we're doing this, we really got to be careful. Just take our time. I made a couple mistakes tonight going through. I know it happens. We fixed it. No big deal. Such is life. But guys, have a great 3-day weekend, and I will see you on Tuesday.